Okay, this video I'm teaching you about grams to gram stoichiometry. When we use the foldable, if it's closed, starts with moles or ends with moles. In order to start with grams, we have to have the foldable open, and we'll use a molar mass on this step to convert it to moles. We'll then use the mole ratio with the coefficients from the equation here. On this side, we must have it open so that we can use molar mass and then convert to grams using molar mass on this step. Okay? Now, remember how we've had mole to mole ratios. Please remember there's no such thing as gram to gram ratios. Here I have some M&Ms. There are 12 M&Ms in here. Here I have 12 butterscotch candies. Butterscotch candies, you know, are much larger than M&Ms. There's 12 here and 12 here. Does that mean they have the same mass? Not a chance. So just because you have the same number of pieces, it does not mean they have the same mass. Atoms are the same way. When we use the periodic table, the atomic masses are very, very different from each other. So even if I did have 1 mole, which is 6.02 times 10 to the 23rd, even if I did have 1 mole of different materials, which would mean I have the same number of atoms or molecules or any type of particle, that does not mean they'll have the same mass. And the simple reason is because they have different molar masses. The molar masses are completely different from each other. Carbon is 12.011, gold is 196.967. They're nowhere close the same. Okay, so let's get on with how to use the foldable. Okay, we're going to just practice it. In the PDF notes, I've provided hints. I'm like talking to you about what we do on each column. Let's just do some problems. So here, I have butane reacting with oxygen, which is basically combustion, to produce carbon dioxide and water. Okay, just a thought. What is the molar mass of oxygen? We're going to need it in this question. I know I need it in this question since the given is 55 grams of oxygen. As soon as it gave me grams of oxygen, I knew I was going to have to get the molar mass of oxygen to even do the question. And then, also, when it asks how many grams of water, then I know I'm going to need the molar mass of water. So I prefer to just go ahead and get it done at the beginning, so I put it as a beginning question. Now, oxygen, if you look at the formula, oxygen is O2. So I can look at the periodic table, 15.999, but that's O. The formula says O2, so I have to multiply by 2, and that gives you 31.998 grams per mole for oxygen, and we do not round the periodic table atomic masses in our class. Okay, notice even though oxygen had 13 for the coefficient here, that is not part of the formula. So should we use the coefficient from the equation to solve for molar mass? No, because the coefficient 13 is not going to always be there. Okay, in this equation, the coefficient's 3, but you see O2 is still oxygen. So whether you have 13 oxygens, or if you have 3 oxygens, or 5, or 25, it doesn't matter. Oxygen is O2. How many of them? That's a different part of the calculation steps. Okay, here I'm asking, what is the molar mass of water? And water, you know, is H2O. If we look up hydrogen, we get 1.008 from the periodic table, and of course there are 2 hydrogens in the formula, plus plus oxygen, which is 15.999, and there's only 1 oxygen in the formula, So we could say times 1, and that will be for the oxygen part of the formula. And if you add that all up, 1.008 times 2 plus 15.999 times 1, you'll get 18.015 grams per mole of water. And that'll be the molar mass of water. When we need it, it's right there ready to go. Okay, let's read the question and start working it. When we have 55 grams of oxygen used up, how many grams of water is produced? Okay, notice what is the given? The 55 grams is on oxygen. That means that oxygen is my given material. And when it says what is the unknown, it's saying how many grams of water. So water is the unknown material. Okay, we've got our molar masses ready to go. We'll start setting up the question. So 55 grams of oxygen. We put the number, the unit, and what it is. Okay, and for the given, of course, we put it over 1. We always put it over 1. Do we want grams of oxygen in our question? No. So grams of oxygen gets copied down here. Grams of oxygen. And as I always teach, if it's not in moles to start with, the first thing we do is convert it to moles, and the foldable, the pattern in the notes also guide us to do that. So moles, and the given material is oxygen. Okay, now we do not want moles of oxygen in our answer, so that means we're ready to cancel moles of oxygen. And again, when we want to cancel something, we copy it to the bottom of the next column. It's like you threw it away down there. Okay, so blue got thrown away down here, it canceled. And now the orange, the moles of oxygen, we're going to copy moles of oxygen, and it gets canceled here. Well, I got moles on the bottom for the very first time. And I've always taught my students when moles is on the bottom for the first time, that's the mole ratio step. So we're going to use moles of given, oh, it's already there. Moles of given's on the bottom, and we'll put moles of unknown on top. Okay, moles, what's the unknown? Oh yeah, the unknown is water. You want to identify that before you even start the question. I do not want moles of water as my answer. We want grams of water. So that means we want to cancel moles of water quickly, okay? We want to cancel that out with moles of water there. If we copy it down here, it will cancel. Moles of water. Again, I don't want moles of water. I want grams of water. And if we follow the foldable, see moles of unknown, that's what I put. And we're now ready to put grams of unknown, which is the water. So, grams of water. Pause this video at any time to replay or repeat anything I've said. Okay, we're ready to put in the numbers. Okay, mole to moles, that's your mole ratio. When we do the mole ratio, we're always going to use the coefficients. Water, I come to the equation, here's water, and you see the 10. So, because 10 is the coefficient, that is why I've used 10 as the number on the moles of water here. Comes straight from the coefficients. Oxygen, notice oxygen's a 13. That's exactly where this number is going to come from, because coefficients are how you fill in the mole ratio step. 10 over 13 because of the coefficients, and you match them up exactly by the formula that's given for it. I still have moles here and here, but remember, when mole is not given, which is here, if mole is not the mole ratio, we're just going to put ones. And if you forget, no problem. Here it says 1, here it says 1. So this one and this one, it's not in the given, it's not in the mole ratio, just put a 1. And the foldable will help you to remember that that's the step we're using at that time. Okay, we have 2 numbers left. Grams of oxygen. And remember right here it says molar mass of the given material, and that's in the very first conversion column. So that's going to be molar mass of oxygen. And we found that before we even began. So the molar mass of oxygen is 31.998. And the molar mass of water, again, we found that at the very beginning, 18.015. And now we can calculate everything. We always multiply the tops. We always divide by the bottoms. So I'm doing 55.0 times 1 if you want, times 10, you have to, times 18.015. Divide by, okay, you can skip the 1, but you have to divide by 31.998. Okay, you have to divide by 13. And you know, dividing by 1 won't change the answer at all, so you can skip that. In fact, I did not even have to multiply by 1 there, did I? I can just skip those. We multiply across the top, we divide all the way across the bottom until every number that's not 1 has been used. Okay, in the calculator, 55 times 10 times 18.015 divided by 31.998 divided by 13 equals, and we get 23.8. Since I have 3 significant figures in my given, that's how I'm choosing 3 significant figures at the end. It says grams, I'm going to put grams, and it's grams of water. So there we go. The unit that did not cancel becomes the unit on the answer. Grams of water in this case. Okay, so again, notice how things cancel. Blue with blue, that's grams of given, moles of given to moles of given. In the mole ratio, we switch to moles of unknown. Moles of unknown cancels with moles of unknown so that I could get its grams. And that's the first gram to gram example.